Good morning, everyone, and thank you for joining us for our final episode of the NTSA and Tech Grove Connect joint venture on webinars around our ITSEC best papers. We've saved the winner of the HPAE category for our last broadcast. And this is, again, I say this every time when we've had some of these, is that this is by far one of my favorite topics because it's so interesting and it really could change the way we look at how we do our training for our warfighters. And I know I've said that before, but it just seems like every time we do these, the technologies and the topics keep getting better. So first, I want to thank NTSA for hosting us and giving us the opportunity to share time with all of you and put together these webinars. And then also thank the folks that are on the call today that will be discussing the topic of, how will measuring situational awareness revolutionize the way we train our warfighters. With us today are Dr. Sandro Silezo and Major Justin Wilson, and they are the primaries on the research. And as always, we're not going to be doing the dive on the analytics and the metrics. What we want to get to is those topics that make it interesting for you as industry, of the how and why, or the aha moments, or how we can take these learnings that these folks have put out there for us and expand on it and make our training better. And so when we get into some of these introductions, understand that Dr. Silezo is very well versed in modeling simulation. He's a former UCF alumni, Go Knights, and so appreciate him being here for that. And then Major Wilson was also a combat flight test trainer. And so there's a lot of experience that has gone into this, from the science, but also the practical application of being a pilot and understanding how situational awareness and measuring that can change the way we dynamically change the training that's delivered to the pilot. So it's not just on-demand training, it's dynamically changing it and how it's perceived and based on the response that the pilot is going through. And it'll be interesting to know, too, then some of the questions that we've already received are, well, how is this applicable to other types of jobs and other types of scenarios? And I'm hoping that our presenters can go into that a little bit for us as well. So with that being said, I'm going to turn it over to you, Dr. Silezo. One note for programming, if you have questions, audience, please put it into the chat and put it into there. Major Wilson is working behind the scenes to curate those and moderate those, as will I. And we'll have an opportunity to circle in on those questions that, one, were presented to us earlier before the presentation, but also as they pop up as the discussion proceeds. So Sandro, over to you, sir.
All right, thanks, Kevin. And by the way, that was half the presentation there, so good job on introducing this topic. And thank you to Central Florida Tech Grove and NTSA for organizing and hosting this. We're very excited to show some of the result and some of the science that we developed to measure SA in real time. And I also, I'm very excited about the audience. I kind of took a peek at who's joining. Very interesting to get your take, and if there's anything that you want to further discuss or potential for collaboration, please feel free to reach out. If you don't have my direct email address, you can find me on LinkedIn. So let's get started. The idea of measuring SA automatically in real time and objectively has been a passion of mine to try to get to that point. Many of you who have been involved in the assessment of higher order cognitive constructs know how difficult it is. Even using subjective tools, a lot of post-hoc analysis going on, it's far from obvious. And things are getting more and more complicated in terms of how the dynamics are evolving with concepts such as the mosaic warfare. But before we get there, I wanted to introduce my co-authors of the ITSEC paper. As Kevin said, I'm not going to get into details of the statistical analysis. This is more of the talking points and kind of get a conversation going. But representing the military, we have Major Justin Wilson, known as Chill. From SMU, unfortunately, Dr. Larson, Eric Larson, could not be here today. I apologize in advance. So we're going to throw him under the bus a little bit throughout the slides. But between Chill and I, we're going to be able to hopefully answer most of the questions you have. So Chill, do you mind giving a quick introduction on yourself?
No, not at all. So I'm Major Justin Wilson. I'm the director of the Academy Center for Cyberspace Research in the Computer and Cyber Science Department at USAFA. I worked with Dr. Larson, who was my advisor, and Dr. Salazio. We worked on this project as well as some others to build some classifiers for cognitive load and gaze classification. We did that over the course of my 3 years at SMU to finish my PhD, and I apologize, I went on a tangent, but yeah, I'll leave it at that.
No, excellent. So here, the important thing to know is that I met Chill when he was a graduate student at SMU. We've had this partnership with the Southern Methodist University right in Dallas. My office is in Arlington, Texas, so they're right in our backyard. They had the expertise we could leverage, and right away, this research, this R&D effort was very fruitful since 2018. So what you see here now is Chill having graduated from SMU and is now faculty at USAFA, and we're continuing the research. One thing we found out that was very fruitful is this collaborative, we call it collaborative thread. It's, and you guys at in the Research Parkway, University of Central Florida, know how important it is to have representative of academia, industry, and military together to solve, big problems. So this dynamic is still going, and our goal is to include as many representatives of the military, small businesses, you name it, to get this going. And as you can see, so that's kind of my goal. I'm the principal human systems scientist now at CAE USA. We were recently acquired by CAE over the summer. Formerly, we were L3Harris, but my role is still the same. I'm still overseeing the human system R&D portfolio. And once the technology gets mature enough, then we transition that into products. So enough with introductions. Let's go to the big questions. Why do we even care to try to measure higher order cognitive constructs, automatically in real time and objectively? Here I'm bringing an example of the Mosaic warfare. Some of you may be familiar with this DARPA. It's a paradigm shift to how traditional warfare is done. Here you're looking at highly interconnected platforms that rely on the resilient platforms to dynamically reallocate complex kill webs. And it's not just based on sensor data or ground truth data. It's also based on psychophysiological states of the various human operators. So having real-time insight of what's going on in the black box here in the brain can really go a long way to optimizing this kill webs. And we are focusing here on SA. You see on the top right box, there's a lot of psychophysiological constructs that one can go after. SA, it's kind of a big deal in the aviation domain, so we focus on that. I know in the audience, hopefully have some former colleagues of mine that, really strongly developed a lot of these technologies for measuring SA that I'll get into a second. But the idea is, really we want to get real-time insights into SA. And this is an incredibly important topic. At the bottom right box, you see the DoD communities of interest, the Human Systems Division really identify this assessment of psychophysiological states as critical for training assessment and readiness monitoring, advancing learning technologies in general, understanding cognitive processes, and being able to sense, monitor, and assess that in real time. What's important about this is that DoD communities of interest really inform Congress on where R&D funding should go in the future. So it's, follow the money type activity. This is a huge area and it's only getting bigger. So that's kind of the why we wanted to tackle this big problem. So now the next big question is, is automated assessment of cognitive constructs possible? Can we even get there? So last year, when we presented this at ITSEC, we thought, we were confident that yes, it is possible. Now this year, we're even more confident. We'll let you know in a second. But this is possible. There's two main reasons. One is the advancement of unobtrusive, easy to use, easy to calibrate COTS devices. So you don't have to spend half an hour donning a student or an operator a lot of biometric sensors, and that may take a long time to get ready. This is a non-starter in a training environment, and you can imagine an operational environment, it's even worse. So this advancement in biometric sensors is great. So the students typically, they only have to wear a Fitbit-like device. Here you see an F4 Empatica. It's got a lot of bio sensors and eye tracking in general, whether it's embedded in a VR headset like we use in our experiment, or just an open eye tracker for an open cockpit environment. It's very unobtrusive. Students and participants, they don't even notice them. So that was very important, right? It needs to be effective in a real training environment, or it really needs to be able to support operations. The second part of this is the advancement in biometric-based machine learning research. And this is why I partner with SMU and Major Wilson here, is to really see what can we do. Can we even develop classifiers that can accurately in real time capture some aspects that we believe are related to situational awareness? The example you see here is from our validated gaze classifier. What you see on the far left is kind of a representation of a HUD, and you see a little heat map of where the pilot gaze convergence was looking at over time. So that's a pattern, and you can train a model to recognize those patterns and then classify them. So that was a big deal when we realized that yes, it is possible to classify scan patterns based on the task. Also, since last year, we've also validated cognitive workload classifier, and it's been published. So if you're interested in that research as well, it can certainly help you, point you in the right direction. But combined, can these classifiers help operationalize situation awareness? So that was kind of our big research question right here. And that leads to how we operationalize SA. Of course, being from the Micah Ansley Schoolhouse, we use our model. So Dr. Micah Ansley literally wrote the book on SA, and the way it's defined, it's actually very simple. There's 3 levels of SA. The first one is perception. What informational element do you need to pay attention to in order to make the right decision to support your goals? The second level is comprehension. Now that you're paying attention to what you're supposed to look at, can you put 2 and 2 together? Can you understand what it means? And of course, the third level is projection. Now that you understand what it means, can you project future system states in order to make the right decisions and support goals and mission objectives? So those 3 levels of SA, we thought that, hey, they're very distinct, and it may be that some machine learning classifiers relate highly with those levels, so they can be used as proxy measures, or they can be used to operationalize part of the SA construct. And if we can get there, then that is a good way to assess SA in real time, because we would show strong correlations with the theoretical model. So that was our starting point. This is how we addressed this big problem. And what we presented at ITSEC last year was a research. So we conducted an experiment with 40 pilots, actually 30 pilots. 10 of them were engineers, kind of our novice group, who have very, rudimentary flight experience, just, building simulators. And we had to pick a scenario that was challenging enough for expert pilots, but not overwhelming for novices. So what we developed is an high altitude air intercept mission where you basically, you're head to head with, I guess, in this case, a MiG-29, and you have to do an intercept and identify friend or foe and do a visual identification of the fin and whether it's loaded with weapons. So that was great because we were able to get novices, and I need to thank Chill here, to kind of get them to a baseline of minimum performance to be able to go through this experiment. What we've done, and let me start the video here so you can get an idea of what this looks like. We use one of our mixed reality training devices. In this case, it's an F-18 training device. You can see the gaze convergence, that little icon, it's where the pilot is looking. You can see where we basically stop the sim, and this is an abridged version, so it's going much faster than the actual scenario. At the bottom right, you can see the various tasks that we're asked to perform, and then going through the motions, having 2 SAGAT stops. So SAGAT is Situational Awareness Global Assessment Technique. This is the gold standard for assessing SA. It's very onerous in that it requires the development of queries, level 1, 2, and 3 queries, so perception, comprehension, and projection queries. So when you see that SAGAT stop is when we freeze the simulation and we ask those queries to the pilots, to the participants, and they have to answer them. That gives us a snapshot of their essay in that particular point in time. So that was the gist of our experiment. Going back to the slides, because at the time our classifiers were not fully built and validated yet, we thought, okay, what's the next best thing that we can use to use proxies for those machine learning classifiers? So we decided to go with the gold standards. So I mentioned SAGAT, we measured SAGAT, but the 2 proxy measures for the workload classifier and the gaze classifiers that we have now validated are the NASA TLX. We use the raw TLX. It's a variant that has no subscale weighting. It's much easier to use in an experimental setting when you want to minimize the disruption and accelerate the flow. So that's what we used. And for the visual scan accuracy, just like the video you just saw, all these videos were recorded, and then we had subject matter experts review those recordings and score them across the level on a 3-point scale on how good the visual scan was, whether it was efficient, acceptable, or unacceptable. And a quick point here is not all SMEs are created equal. And a lot of you probably know that. Inter-rater reliability, sometimes it's mind-blowing how bad it can be when you're looking at different SMEs. But in this case, I want to, again, personally thank Opie and Mole. So Keith Taylor and Bill Johnson were my 2 SMEs. Highlighting in their bios here, you can see they were Top Gun instructors with thousands of hours flying and instructing students. And the way we proceeded with this scoring, using them as basically identifying ground truth and scoring visual scan accuracy, so on and so forth, is with a straightforward 2-step scoring procedures. They independently reviewed and scored, and then where discrepancies existed, then they reconciled those differences. And what you see at the bottom is the final agreement. So even if they had a joint session where they had to reconcile all their differences, they still had a little bit, 1.5% disagreement. So it shows you that even at that top level, human minds, they will still have their own little biases that will make subtle changes in how someone will score an individual. So that was interesting. But regardless, I mean, almost 100%. So this was a very, very high agreement. I'm not going to delve into our statistical analysis and what we found. That's available in the ITSEC paper. It's available on the ITSEC website. If you cannot have access to it, let me know. I'll provide you with a copy. But what I really wanted to show was the overall outcome. So we had a lot of hypotheses going in. This is our hypothesis matrix that you see here, and we were surprised that most hypotheses were supported or partly supported. The most difficult part, and for those that are familiar with SA measurement, level 3 was a little harder. We had not as many verbal queries for level 3 SA, which is projection, and it's much harder to get a good level 3 snapshot because of the difficulty of these queries. So what you're seeing here is that had we had more queries and had the scenario perhaps been a little bit more rich, we would have been confident to find a strong relationship there as well. But overall insights is that training effects. Oh, by the way, we had those participants fly the same mission that you saw twice. We wanted to see if our hypothesized training effects would be manifest, and indeed they were. So we find that overall SA got better across those two high intercept missions, and workload decreased. Unfortunately, we didn't find the same thing on performance, but then again, we believe that with a larger sample, we would have found differences there as well. Something interesting was an interaction showing that workload decreased with additional training, as expected, for all expertise levels, but not for novices. And here the explanation is that it may be that on the second event, novices were actually able to grasp mission objectives, so their workload increased. They said, oh, now I think I understand a little bit better what's going on, and they could put 2 and 2 together, that comprehension, level 2 SA, and hence the workload went up. So overall limitations, it was 40 participants, and those that are familiar with running complex human subjects experiments, 40 is a big deal. And of course, you want more data, but at the time, that's all we could do. And we still found very strong effect sizes. So most of the significant relationships that we found here was thanks to that effect size, which is an indication that the manipulations were good, and that the effects we were looking at are real and existing. So that's a snapshot of our findings. If you want to know more, please refer to the ITSEC paper. But let's look a little bit at our question, right? Can we use gaze accuracy and mental workload as valid proxies of situational awareness? So the answer is that, wow, yes, we're getting there. There's really tangible possibility here. You can see that visual scan accuracy can be used as a proxy for a gaze classification. And now that we have this gaze classification working, we're excited to see what we can do with it. Visual scan accuracy is strongly related to level 1 SA perception. It makes sense, right? What am I supposed to be looking at in the environment based on my tasks, my goals? And for pilots, many times there's a very prescribed scan pattern that needs to be done. And now with a gaze classifier, you can capture that. And hence you can see that strong correlation with level 1 SA. And visual scan accuracy is also related to level 2 SA. You need to work hard at capturing those visual elements in the environment. So that's going to have an impact on your workload. And finally, visual scan accuracy and performance are also strongly related. So it makes sense. If you pay attention to what you're supposed to be paying attention, and you can put 2 and 2 together, then you're going to make the right decisions, and your mission outcome will be, enhanced. So the second part here is workload, and using workload classifier as a proxy for level 2 SA. And we indeed found that workload is related with SAs level 1 and 2. Here, the idea is that level 1 and 2, maybe using working memory resources so you can see an impact on the workload. We didn't find that necessarily as strongly for level 3 SA, the projection, because when you engage in projections, it really means you've reached a certain level of expertise and you use top-down processing. So there's much less going on in working memory. It's all based on your schemas that you've assimilated over time. And so the impact on workload is diminished. And that's what you want, right? In a training environment, you want to bring a novice to an expert level. So they go from a bottom-up information acquisition to then a top-down processing. So all that was verified. And I want Chill actually talk to the last point here, the lack of relationship that we found between mental workload and performance.
Yeah, sure. So that lack of a relationship actually exists in the literature. Our experiment essentially validated that concept. So you can potentially have many different levels of workload to achieve a given level of performance between subjects. So one subject might think a task is excruciatingly hard, but still succeed, while another subject thinks it's very, very easy. And that could very well be based on their experiences and their knowledge. But that's really, or that makes things very difficult when you're trying to, say, create a objective cognitive load classifier. And that's something you have to take into account. And when we went and developed our classifier, we actually had to design the experiment to support it in such a way that we were capable of aligning the subjective labels to discern who is actually loaded and where, if you're going to try to do a cross-subject classifier. So this is very much a great result because it actually reflects the literature that different subjects are going to have different, or will have different levels of workload for a given metric of performance.
So thanks, Chill. Yeah, so this is great, right? Because even if you think about it from human factors literature, if you think about Hancock and Warm and that zone of maximal adaptability, where you want to keep your students at to progress best in a training environment, this confirms it. So now comes the implications of our research. And there's a ton of implications, and most of you can already think about, where we can go next with this. But if you have a real-time glimpse into a pilot's situation awareness, you can identify in real time a breakdown in perception. For example, thanks to Sergey's classifier, and then you can intervene. As you all know, this paradigm shift towards an adaptive training environment is coming really fast. And we want to make sure that we have the right tools to inform an automated system on how to manipulate your training environment in real time. And knowing SA is one of those factors that will go a long way towards optimizing your training environment. Also, there's implications for mission readiness that can be achieved more effectively and rapidly if we know a pilot's SA in real time. Is that particular pilot ready to tackle the mission, right? How much rehearsal needs to occur, for example? So that's an implication for training. Implications for operations is going back to my early example of the mosaic warfare. So real-time SA here could lead to a more effective dynamic reconfiguration of warfighting platforms, of this complex skill webs that, readjust based on what's happening on the ground. And having insights into a pilot's SA can help optimize that configuration. And also, real-time SA can help prevent breakdown in decision-making or identifying loss of SA can also have system automatically alert the pilot. I know we've had recently hypoxia incidents where pilots, when they go above 10,000 feet, they have to do a check, and Chill can be better able than me to explain what goes on there. But in a nutshell, you need to verify that the oxygen is there, and if not, it can lead to hypoxia. And many times it's kind of a muscle memory. The pilot will verbally announce that yes, they've done the check, but you don't know whether they really did or not. So now real-time SA with the gaze and the workload, you can actually have an indication, a much better indication of whether that check was done properly. So a ton of implications, and this is just a starting point. I want Chill right now to give a little bit of a glimpse of what we're going to do next.
Right. So where are we going next? Well, one, we definitely want to improve our classifiers. 40 subjects is great, but if you know anything about machine learning or deep learning, the model is only as good as the quality of your data. So, or the quality and the amount of your data. If you don't have good quality, at least have more data. So we want to collect more data. Our cognitive load classifier can only do low and high load right now, but it works. It's validated cross-subject with a little over 80% accuracy on just the E4. It improves a little bit when you add pupil, but we want to expand that. We want to increase the resolution on that. We want to add more tasks to our gaze classifier. The gaze classification is fairly straightforward. You can take advantage through transfer learning of the many deep neural networks out there, like VGG, if you're familiar, that have been trained on millions of images, and you can take advantage of those learned hierarchical relationships. And so really, it's just a matter of collecting the necessary data for a given task. But each task is under many tasks in aviation, so that can be quite tedious. So we want to improve our classifiers. We also want to conduct the analysis that we did in this paper, but with the actual classifiers. Then with more data, we haven't given up on level 3. So one of the things we came across is we weren't able to statistically show that level 3 is related to mental workload. I think with more data and using, rather than the subjective labels, the alignment technique we used in our cognitive load paper, we have a real shot at showing that. So we want to design a better experiment that is capable of, that has more questions that will elucidate our ability to classify level 3 or get there. So Eric's not with us, but he and his current grad student are working on turning our data into a SA index. With an SA index, we can then take advantage of deep multimodal learning, which is what we use for our cognitive load classifier, to then extend that, and hopefully the goal is to classify level 1 and 2 SA with the architectures we have and anything else we can add to it. So ultimately, improve our classifiers, do more experiments, and take what we have and build a level 1 and 2 classifier.
Yes, thanks, Chill. So we think that by the end of the year, we're going to have a rudimentary, let's say, real-time index of SA. As you can see at the bottom left picture, we're going to have a classifier for level 1 and level 2 SA, and we want to push the research in that direction. So we invite all of you to apply this research to your domain. We looked at pilots because necessarily, biggest part of our wheelhouse is to train pilots. And so that was a no-brainer for us. But this is applicable to any dynamic high-stakes domain. It's applicable to maintainers. As a matter of fact, we're trying to migrate this research with maintenance. There's a lot of the same problems that affect that domain. So it's really widespread application. And we would like to know, from the audience, your questions, what you think, your concerns, or how you can help push the state of the art in this domain, and let's see what we can do. So this is the end of the formal brief.
Thank you, guys. That was it's very interesting. And while I see some of the questions are queuing up, Chill, if you could take a look at some of those and begin to formulate some answers. I have one for you guys that's just off the top of my head. Now, I am novice. I'm certainly not a cognitive engineer or a scientist in this range, but I'm curious. The indexes that you're creating, would these become part of a larger public library that would be accessible to the Air Force or to anybody that's looking to build some of these training applications? And are they measuring what good looks like, and then are they applicable across other procedures, other flight type procedures, or other military exercises, that sort of thing? So kind of a two-part question.
Yes, and that's a very good question, by the way. So the science on how we develop those classifiers, we publish those. Of course, the tasks that we train the classifiers on are from syllabi of actual training that at least now CAE is undertaking. So the part that ends up in our product, that it's IP, but the recipe for you to create your own, that's the science part of it, and that's what we're publishing and releasing to the public domain.
Okay, thank you.
So I basically did not answer your question.
No, you did. So I mean, yeah, you're right. No, it is IP. I mean, it's work that you've done, but it's like anything. If someone understands the process and the methodology by which you're creating that, then they can replicate it and create a part of their own. But I didn't know if part of that work that was brought financed by the Air Force would then go into a public domain, so that there's commonality, that this particular training procedure in the T6 is performed this way, and here's the index for performance by the student that we expect them to hit, and it's this level, right? So
quick two answers on that. Sorry, Chill, real quick. So, first of all, this experiment was a purely internal R&D. So it was funded by, at the time, L3Harris and now CAE. But second, the Air Force is going to benefit this, because we're also involved with the DIU Pilot Training Transformation Program, and we also are in control of the IFT Initial Flight Training Schoolhouse in Pueblo, Colorado. So once the science is validated and injected into a training program, that's where the Air Force will see benefits from this.
Awesome. So just as a note, so I don't forget, is that I think perhaps you should be talking with the folks at AFMS here in Orlando around some of the policy, because I think that could have some interesting some interesting paths, because I know they're trying to get some PTN trainers here and put them into the Tech Grove, and having some of these baseline SA type tools available to a wider audience on the PTN, as people are experimenting with different visual technologies and bioanalytics, might be an interesting avenue to help grow that ecosystem of these classifiers. But just some food for thought there.
Absolutely, and I think this is part of the conversation we want to have here, is to see where additional collaborative opportunities may exist. Again, the science, we're very transparent in our research and what we're doing, and we want the whole world to benefit from this. So if there's a way that we can collaborate with additional entities, we're obviously very, very open to support this.
Awesome. Okay. Hey, Chill, I was going to kind of toss it over to you, because I know you've been looking at some of the Q&A. You want to try and tackle some of these?
Most of these would probably be in Sandro's wheelhouse. I will say that, just to clarify from the previous discussion, if anyone doesn't understand how the PhD works, when you go to a civilian institution on active duty, you have to go find funding. So in my case, SMU funded my research, which is why it wasn't a military funded experiment. That was done entirely between SMU and L3 Harris at the time, now CAE. Back to these questions. I think, Sandra, if you want to look at that first question.
Oh, Dr. Davis. Yeah, I'll take that one. So let's see. Could you provide a quick example of how using proxies to measure essay, how that would work? For example, how could the essay data be used to adjust training intervention? So that's a relationship between what we can do measuring real-time essay and inform training interventions. The example I gave earlier of the hypoxia check was a straightforward one, but are you performing that check? And with an essay index, you can not only verify that the check was visually done, but if the right workload was applied, then you can infer that that was processed properly. So if there's an issue there, you can have an automated coaching system that that tells you, hey, do your reading better. But in general, Fleet, as you know, there's many different ways training can be adapted, and you've actually done your dissertation on it. But what we're looking at is the way essay can be best used, in my opinion, is to do within training event adaptation as opposed to across training event or between training events. So here is again to make sure that the difficulty is adjusted so that based on your essay as a in addition to just based on your performance. So there's many different interventions that can happen there. That's based on the syllabus and the training tasks you're trying to learn.
One of the questions I thought was interesting, and when I was talking with Eric or Dr. Larson, I think it was more, there were some other biometrics that you were tracking aside from the eyes, and he was saying that you could actually see throttle response and stick response as well as another measurement that was contributing to situational awareness. So it wasn't just the eye gaze. So I'm wondering if maybe you could expand on some of the other technologies that could be incorporated. And as a follow-on question to that is, are there too many sensors and too much data that can then overwhelm the development of these machine learning tools, that it just overwhelms it and it becomes just too much data and it's not as effective?
Yeah, so I'll start the answer and I'll let Chill finish the answer. So we use two basically sensors. One is eye tracking, which has pupil dilation and gaze convergence. So that's kind of what we used for the gaze convergence classifier, of course. But for cognitive load, we use an E4 Empatica device. It's a wrist-worn device, and it's got a collection of sensors in the back that provides telemetry on a lot of biometric indicators, such as let's see, it's got heart rate variability, it's got EDA, whether it's phasic or tonic. It provides insights into both. It's got an accelerometer. So because we put the wrist-worn device on the left wrist, we could see how a pilot would use the throttle inputs. And that's a lot of great information to, at least for this particular use case, very beneficial for us to build a classifier that is germane to that environment. And Chill, is there any such thing as too much data?
No, you're not going to overwhelm the model because you're the one that designed the architecture, and it's accepting a set amount of features. Now, our cognitive mode classifier accepted variable input, which actually really slowed down the training. But you're not. More data is better. You're not going to overload it. When you're taking into account all these different sensor streams, you will have to come up with a mechanism for aligning them in time. But that is before you input them into the model.
Awesome. So looking back at some of these other questions that were beginning to flow through, Dr. Slater, I'm gonna leave it to you based on what you know and what you've been able to assess here to address some of these questions. And I'm going to look at the ones that were given to us yesterday. But if you could look at some of the ones that were popping up from this morning from the attendees, I'll look at some of the others from the Word document.
Sure. So let me go in order here. Do you think these principles could translate into training in a sustainment arena and for equipment maintainers? So yes, and I think I've alluded to that earlier. We are actually actively looking to translate those findings into the maintenance world right now. And it's just not maintenance, it's, load masters, whatever other main functions that you can think of on the flight line or airborne. All these roles, there's applicability. And again, we focused on pilots first, but absolutely you can translate, because you think about SA, when you're in a dynamic environment, any role will have you will have a say for the job and the task at hand, right? So you will always have to scan the environment to look at what's important to you. If you're a maintainer, you'll have to look at the system you're looking at, the right components you're supposed to look at, and then your tech manual, whatever you're using. So there's a scan pattern there as well. Your goals and decisions, it is the same thing. So theoretically, you can apply this to any type of dynamic, domain. So yes. How cumbersome is the NASA TLX we're adding to the training equipment? So we want to. Yeah, go ahead.
Go ahead.
Oh, me? Did you answer that one?
Yeah, go ahead. You can take it. I was just responding to it, but you can have it. Go ahead.
Hopefully our responses are the same. We want to get away from NASA TLX. That's the whole goal of developing a real-time classifier, because those traditional gold standards are cumbersome, right? They require a lot of planning and a lot of post-hoc analysis. So it's not something you can use in a real-time training environment. I mean, it's great for science. And they've been around for, oh my gosh, decades, right? Since what, the 70s or more? I don't know. So they've been around for a while. So it's time for a change. And I know, the academia, the military and industry, we're all trying to accelerate that shift towards these objective real-time measures of higher order cognitive constructs. So, yeah, go ahead, Kevin.
So another one I think kind of ties into that too is, there's two. One is the common operation picture, and then in terms of, can the technique be expanded to larger environments, such as a staff trying to understand the situation from an incomplete and time-deleted common operating picture?
So that's super interesting. There's another R&D effort we are currently undertaking. It's human-machine teaming, but it also takes the picture from the individual to the team and team of teams. So common operating picture, you think about a joint C2 environment where you have a number of stakeholders that have to collaborate. So that's the next step, right? And the theory is already there. We know how to assess shared SA and team SA. So it's just a translation at a higher level, but you need to have it nailed at the individual level before you can move it up a notch and looking at kind of a team environment, team dynamics, whether it's a common operating picture or a joint command control type of environment. There's a lot more complexities there. So if anybody's interested in helping solve that big problem, and it's a huge problem, right? You just seen that Congress allocated a huge budget for joint all domain command and control. So I mean, human stakeholders are going to be in the loop. There's going to be a lot more AI and automated systems that they're going to help them make the right decisions. But those that are familiar with the human factors literature is that if the systems are not developed well and do not support the operator or the decision maker, then you're going to have human error. And unfortunately, typically the human gets blamed when it's the system that should be blamed. So our job is to make sure we get to a point where the overall system truly supports the cognitive capabilities of operators.
Yeah, I think that subject, along with the influence of like synthetic teammates or other AI technologies that are coming in, that's really opens the aperture, right? Because
It does.
it changes things so dynamically. And I think too, for the larger like LVC picture, this might be a good conversation for you to have with NOC TSD around their LVC docs, system that they have here, and what tools CAE or folks on the call here might want to layer into what the work that they're doing around developing a common architecture around LVC type applications and taking these types of scenarios and plugging them in. So that might be another avenue for you to pursue as well. Hey, we're coming up to the top of the hour, and I've got a couple more questions that I think we could answer, but I do have one question at the very end I do want to pose to you around finance. But Jill, is there's some other questions here that you want to bubble up, or Dr. Salazzo, is there another couple questions that you want to bubble up to make sure we address?
Jill, have you seen any questions that you've answered that we haven't tackled yet?
Sorry, I'm having
typing. He's probably typing as we speak. So let me see. I'm going to read some other questions here.
Well, one was, is this transfer to Army, type warfare training and maintenance type training? Is this applicable to beyond just like pilot and technical execution?
So absolutely, it's an all domain type problem, and
okay.
we've developed a framework of across domain essay assessment. And as a matter of fact, I think it's okay for me to say right now that from an Army standpoint, we're looking at dismounted infantry. That's been a low-hanging fruit for us to tackle. Now that we're CAE and we have more connections in the Army domain, it's something definitely we're interested to pursue. We're looking for CRAD to support those efforts. So if anybody in the audience is interested in that, feel free to reach out. We'll see what's possible.
Excellent. And then early on, you mentioned, and just a few moments ago, you also mentioned around the funding and the opportunities. I'm wondering if maybe you can expand on what that funding might look like, or what the avenues are that people should be looking at. Should they be looking at DIU, or they should be looking at CIBR or research grants? What's a good avenue for one, advancing the state of the art of the classifiers and pairing up and building on situational awareness with the funding that might be available?
That's a really important question. I don't have a perfect answer for that. All I know is that, we're really trying to have a healthy ecosystem of partners, whether they're in the military, academia, and with small businesses. So we are transition partners to small businesses that are on CIBRs, for example, and we help them there when what they're developing is aligned to some of our research and to some of the products we're trying to better. So it takes a village, right? So the more at the table, the better. When the key is to find a way to promote that research. There's different venues. I mentioned that I'm primarily involved with internal research and development, but we've successfully attracted CRAD from DoD labs, and we're also sponsoring small businesses to help us with whether it be bettering some components of the training environment. So we're open to kind of all of the above.
Excellent. So a couple of folks have been asking, what's the best way to reach out to you and your team and to connect with you? Is there an email address, or is there a website? What's the best way for them to funnel their questions and follow up?
Yeah, sure. So again, this agreement that we have with United States Force Academy and SMU, it's formalized under a CRADA. So if you have questions directly related to what we presented today, you can reach out to Eric, Chill, or myself. We're on LinkedIn. If you have LinkedIn, you're going to find us. If there's a direct email, so my direct email is firstname.lastname@caemailusa. So Sandra.Chielso@caemailusa.com, and you can get in touch with me that way.
You can email me directly. My email is justin.wilson@afacademy.af.edu.
Okay. And this will be, this session has been recorded and will be posted in the next few days. So if there's some finer points that you want to go back and review, before you funnel your questions over, make sure that you check out the video once it gets published. And I want to thank you, gentlemen, for the great discussion. This has been fun. I mean, it's fun to be early in the career of something that's really changing the way we're going to train our warfighters going forward. And I think with the technology and the biometrics and the capability to actually measure the current situational awareness of the student is so far beyond what we've had in the last 20 to 30 years in terms of the training and how it's going to train, or how we're going to adopt that and incorporate that into our training. I'm really looking forward to seeing this research expand and seeing the results start to manifest in the training as it goes out to the warfighters. So thank you, gentlemen. We appreciate your time. And everybody that's on the call, thank you again for attending. And we look forward to doing this next year, where we tackle, again, the best paper that come out of ITSEC. These have been really good topics that come out. And the feedback that we've gotten from the folks in the field is that these are the types of discussions that they can't necessarily get into at ITSEC because we're going through a lot of the research and the numbers. But this is the nice discussion that follows up and that really starts to change the industry because it's collaborative and we get a lot of good information from the aha moments. So again, gentlemen, thank you. And NTSA, thank you very much. And everybody, ITSEC is just a couple months away. The papers are already submitted, so looking forward to seeing everybody in person here in Orlando. And take care, and we'll see you in a couple months at ITSEC, guys. Thank you.
Thanks, Kevin.